So as we had said, we are coming back to scientific inquiry.
Yeah.
This time, not the observational stuff we did last time, but theoretical scientific inquiry.
Incidentally, Sriram is behind the camera, so he might be asking some questions.
Yeah, he's replaced Tara for this video. So what we're doing is theoretical scientific inquiry.
Right.
So what is theoretical scientific inquiry?
Let me say what is theoretical inquiry in science, as opposed to theoretical inquiry in other areas outside of science.
In mathematics, we talked about what it was.
That. So there can be theoretical inquiry in philosophy, but we are not dealing with that kind of, or aesthetic theories. That's not what we're dealing with, or moral theories. So we did talk about two aspects of scientific inquiry as part of observational inquiry. So scientific inquiry has two components. One is observational inquiry, and the other is the theoretical inquiry. Occasionally, when people are making a distinction between theoretical inquiry and this part, they refer to this as experimental inquiry, or experimental inquiry in experimental science. I don't want to say experimental because there are aspects of observational inquiry which do not have
astronomy, for example.
Astronomy, exactly.
Astronomy.
Yeah. Physics, of course.
Evolution, biology.
This is necessarily experimental in physics. Okay. Here, we made a distinction between data points, which is information about a particular entity in an observational report, and a collection of data points that we call sample of data points, and then projection from the sample to population. And the generalization made on a sample extended to population, which we call observational generalization.
One other thing we did when we did experimental inquiry was determining whether there's cause.
Cause, yes. Yes, so we also made a distinction between correlation and causation.
So that would be
all that will be part of
causal observation generalization and correlational observation.
Yeah, I wouldn't say causal observation, I would say causal correlation.
Causal,
right? Yeah, there's a connection between two variables that could simply be correlational, or but you could attribute causation.
Could you give an example of correlational and causational inquiry?
Yes. The classic example that most people give in most textbooks, and that's the one that I would use here, is between smoking and cancer. Suppose you examine a large number of people in a sample, people who are smoking and people who have cancer, and then you find there is a larger incidence of cancer among the smoking population and fewer people who have cancer in the non-smoking population. Then you say there is a correlation. Okay, so this is the correlational hypothesis, that smoking and cancer are correlated. There is a systematic relation between the two. This is exactly like saying if you have a circle and you have a diameter and a circumference, there is a correlation between the diameter and circumference. If you know this, you can figure out this. If you know this, you can figure this out. Same, but you're not saying that the circumference causes the diameter in this case. Okay.
But over there you might say that smoking causes cancer.
Right. You could say smoking is the cause of cancer and this is the effect, cancer. Alternatively, you could say, if you have cancer, you tend to smoke. In which case, this is the cause and this is the effect.
So that's a choice at this stage. When you figure out there's a correlation, now I can attribute cause to either of two, or there can be something else, which is a cause, and it causes both of these, and both of these are the effect.
So maybe there is some kind of gene which causes both smoking behavior and cancer. Right? So causal research is actually much more demanding than correlational research. when people say, so this is the observational experimental science, this part. There is what is called hypothesis testing model. In most school textbooks, this is what is given as science. They restrict themselves to this branch of science. But there is another dimension of science, which is constructing theories, that is, when you have observational generalizations, you have to construct explanations. And that is the job of theoretical inquiry. And given the same set of observational generalizations, you could construct different explanations. And how do you choose between those different explanations is an important part of theoretical inquiry. That is what we want to do today. We have done this part. Now we proceed to this part.